Okay, now let us learn the laws of refraction. Okay, just we had laws in reflection, we also have laws in refraction. The first law is very similar to our laws of reflection. It says that the incident ray normal ray, or you just say normal, and the reflected ray, the refracted ray, sorry, incident ray, normal and refracted ray all lie at same plane at the point of incidence. Okay, what does this mean? That suppose this is my separating surface, this is my medium 1, medium 2, this is my eraser, this is my denser. Okay, and let's draw normal. So suppose if this is my incident ray and this is my refracted ray, so this is my I, this is my R, this is N. So all these three rays are at same plane, in the same plane. Okay, they are not in a different planes. So they are all are in the same plane at this point of incidence. This is my point of incidence. Right? First law is clear. It's very simple. Again, all the rays are in the same plane. Let us move on to the second law. Second law is basically about the refractive index, and it is also known as my Snell's law. What it says is that suppose this is my normal and right, this is my angle I, angle R, correct? Medium 1 with refractive index N1, medium 2 with refractive index N2. The Snell's law says that sin I upon sin R is equal to N2 by N1. In all the books, I have seen lots of books, in all the books this second law is always in this form, but I prefer to write this in the form of that refractive index of any medium multiplied by sine of that angle which is made in that medium with the normal is a constant, right? The product of these two, the refractive index and sine of angle which is there in that medium only. Okay, so what it gives me like, if I write it for N1 medium, it will be what? N1 multiplied by sin I, and this is equal to K. And for N2 medium, if I write N2 sin R, because R is angle, this is also K. From this 1 and 2 we can write N1 sin I is equal to N2 sin R. Got this concept? And N1 sin I is equal to N2 sin R. And if you just rearrange the things, sin I by sin R, it will come as N2 by sin. Correct? So I prefer to write Snell's law in this form. You can do it in this form also. Now we need to understand what is this N2 by N1. Okay, this N2 by N1 is basically a ratio, or you can say we use ratio for what? Comparison, right? So we are comparing two mediums. So we can always say this, that this is refractive index of medium. This is my M2 medium, this is my M1. The refractive index of M2 with respect to medium M1. So basically what we are doing, we are comparing two mediums, N2 and N1, right? So this is what refractive index of M2 with respect to M1, and we also write this in the form of 1 and 2, right? So basically this is the refractive index of N2 with respect to first medium, right? 1 and 2, correct? Now suppose if the ray is coming from denser medium and it is moving away, this is my I, this is my R. Okay, in this case students get confused with this formula, right? Because it says refractive index of medium 2 with respect to medium 1, but if we follow this rule, here we can write this. Okay, let us state this. Here we can write, this is my N2, this is my N1. N2 sin I, because now my angle of incidence is I, is equal to what? N1 sin R. So in this case we got N1 by N2. But we remember the concept that refractive index and sine of angle in that medium is always constant. Okay, here what it will give me, sin A by sin R, it will give me a refractive index of N1 with respect to N2. Okay, so just remember the terminology. That so Snell's law is what? Snell's law says that the refractive index of any one medium with respect to other medium is given by ratio of sin I and sin R, where I is what? Angle of incidence in medium 1 and R is what? Angle of refraction in medium 2. Okay, so just remember either this formula, this form, or this form, right? This form. So these are my two laws of refraction. Let us understand the refractive index in terms of its component, means speed, wavelength, or frequency. Okay, a light wave, right, a ray of light has three things. One is speed, you already know, frequency and wavelength. Okay, and we already know that speed decreases or increases if the medium changes, right? And it depends on refractive index basically. Okay, now we know one formula, basic formula in physics, that distance is equal to what? Speed into time, correct? So my distance is wavelength and speed is v, and this time basically what? And we can write 1 upon frequency. So we have one formula which is v is equal to nu lambda. Remember this formula always, right? That for any wave we have v is equal to speed is equal to wavelength multiplied by frequency, correct? Now one more important point, that when a light changes from one medium to another medium, only one thing which doesn't change is its frequency, right? Remember this point. Frequency doesn't change when medium changes, because it depends on the source of the source of the ray of the light, you can say. Okay, and frequency never changes even if medium changes, right? Remember this thing. Now we will understand refractive index in terms of speed. Okay, we know that speed of light in air is what, and we denote it as c, which is 3 into 10 raised to 8 meter per second, right? And we also know that the refractive index of air is what, 1, correct? And for other medium it is greater than 1, and we all know that if light enters into another medium, its speed decreases from air. So let us say that speed is v, okay, speed in other medium, right? And my n2 is, let's say, n1. n2 is the refractive index of second medium, right? So we have a relationship between these fours. What is that? It says that n2 by n1. What is n2 by n1? We already know this. The refractive index of medium 2 with respect to medium 1 is equal to c by v. Okay. So from this we can say that this n1 was what? This air, or you can say the refractive index of first medium. So if you just write it in this way, it is similar to Snell's law, where we say that the product of refractive index and the speed of light is basically what? Constant. The product of speed of light and the refractive index, this is what? A constant. So remember this thing, right? The speed of Snell's law you can write in this form also. n1 into v1 is equal to n2 into v2, right? So let us write this. n1 v1 is equal to what? n2 v2, where v1 and v2 are what? Speed of light in medium 1 and medium 2, right? One relationship, you understand this? Now next, since we know that v is equal to nu lambda, and nu, which is frequency, it never changes, so we can write n1 multiply by, for v1 we can write nu lambda 1. Lambda changes, right? Nu is not changing. n2 nu lambda 2. This nu will get cancelled, so we have another relationship in terms of lambda and refractive index, correct? So if refractive index is higher, my speed decreases. Similarly, if refractive index is higher, my lambda also decreases. So this is the relationship between speed and wavelength with refractive index. So now we know basically three things about refractive index. One is what? You can say that n1 sin I is equal to n2 sin R. n1 v1 is equal to n2 v2, and n1 lambda 1 is equal to n2 lambda 2, right? So we have three relationships with respect to my refractive index. From here we can conclude that if the wavelength is high, my refractive index is low, right? If the wavelength is high, my refractive index is low, because product of both the things should be a constant. Similarly, we can write here that if the speed is more, refractive index is less. If speed is less, the refractive index is more. Okay. Similarly, if the angle is more, my refractive index is less. right? So this is my relationship between these three things. And one more thing, we know that denser medium and rarer medium. Denser medium is what? Where the refractive index is more than the rarer medium. Now let us understand the concept of principle of reversibility, right? We have seen that two mediums N1 and N2 with a refractive index say N1 and N2, and suppose this is my normal, and suppose this is my incident ray making an angle I, and this is my refracted ray making an angle R, right? We can write one relation here, which is N1 sin I is equal to N2 sin R, right? Now these angles are basically what? Acute angles, less than 90 degree in all the cases, okay? Now the principle of reversibility is what? That if the ray starts coming from here, from denser to rarer, this is my denser, this is my rarer. Suppose my ray starts coming from denser to rarer with the same angle, which angle is R, okay? So will it travel the same path or not? We need to conclude this, right? Let us find out, okay? So let us say that my initial angle is what? R. So we can write here that N2 into sin R. We can write it here, but product of the refractive index of this medium into the sine of the angle which is making in that medium, which is equal to, again, product of what? N1 multiplied by, suppose this angle is not I, let us say I dash, or any other angle you can write, right? So N2 sin R will give you what? N1 sin I dash. From these two equations we can conclude that this N1 sin I is equal to N1 sin I dash, because both are equal to what? N2 sin R. Here N1 gets cancelled, sin I is equal to sin I dash, and for the angles which is less than 90 degree, we can always say if sin I is equal to sin I dash, I is equal to I dash. What does this mean? It means that my refracted ray, now if I am talking about, this is my incident ray, this is my refracted ray. The refracted ray will travel the same path, okay, when it was coming from this. So this is known as my principle of reversibility, that if a light is entering at an angle I and making angle R in while refracting, okay, so if a light enters with an angle R, it will go with angle I. This is known as my principle of reversibility, right? It traces the same path, right?